Hi, we're Dangerously Warm. This is our project, Sorta Cool. It's an automatic item sorter. I'm Eric. I worked on the mechanical components, dispensing, conveyor, and collecting.
I'm Yonki and I worked on Raspberry Pi and camera.
I'm Derek. I worked on the PCB and the Bluetooth.
I'm Bo and I worked on the LCD and touchscreen.
Yeah. This is our dispenser. Our dispenser individually dispenses every item 2.5 seconds at a time. This is based on a timer and a DC motor on an H-bridge that will reverse the motor to prevent jamming. As you can see, there's a slot to dispense every candy through this hole. The conveyor is controlled by a DC motor on an H-bridge to enable and disable the conveyor. When a candy enters the IR sensor, it triggers an interrupt to gather information from the camera. As the camera detects the color of the starburst, the stepper motor rotates to collect it in the correct bin. The stepper motor is able to increment at precise positions and is calibrated with a magnet sensor in the back. The LEDs light up corresponding to the color that was detected.
The Raspberry Pi takes a picture when on the IR sensor interact. Raspberry Pi processes the image and detect pixel-wise what color has been detected, and then it sends a UART message to the Smart Fusion. In the meanwhile, the Raspberry Pi sends a Bluetooth information to the remote controller. It also receives the Bluetooth information sent from the remote controller to stop and start the motor by triggering a GPIO interact on the Smart Fusion.
We have a controller that connects with our main sorter via Bluetooth. The controller has two main features. It has an LCD monitor to display the amount of candy collected so far, and also it has a start, reset, stop button to start and stop the motors and to reset the counts. Here we see the red starburst detected, so the count for red goes up by 1. We can disable the motors by pressing stop, and we can re-enable the motors by pressing start. The touchscreen controller is packaged to fit multiple components inside. Internally, there's our Smart Fusion that connects all the smaller parts together. There's a 6-volt battery pack that is connected to a voltage regulator that turns the 6 volts into 5 volts, which then feeds the power into the Smart Fusion and other components. There's the LCD plus touchscreen that is also connected to a touchscreen controller, and there's a Bluetooth adapter. The LCD communicates with the Smart Fusion via SPI, and the touchscreen controller communicates with the Smart Fusion via I2C.
This small board is the Bluetooth low energy module. The blinking red light signifies that it's on, and the solid blue line signifies that it's connected to another device, in this case the Raspberry Pi on our system. So the Bluetooth module is controlled by the Smart Fusion, and the Smart Fusion sends commands to the Bluetooth module over SPI, and these commands could be requesting information or commanding the module to send information. Currently the Smart Fusion commands the Bluetooth board to send an on-off signal to the Raspberry Pi to turn the main system on or off, and the Smart Fusion also commands the Bluetooth module to pull for color data that's sent by the Raspberry Pi, and when it receives that color data, it will update the LCD. This board behind the jungle of wires is our custom-made PCB. It distributes power to all of the modules in our system, so it functions as a power distribution module, and it contains 3 of our H-bridges for our motors, and this is one of them, and then the other 2 are underneath.